Absolute value strategies. With absolute value equations, we follow the rules of algebra until we arrive at one of the following forms. We have the absolute value of x minus c equals d, or we have the absolute value of ax minus b equals d. So at this point, there's really two strategies. The first that leverages the graph, and the second that leverages the definition of absolute value. Here's where we leverage the graph, where the center is C and your distance is D. And the second, we're really using algebra and that definition that you can set either, or you can set the expression in the absolute value equal to positive or negative D. So this really reveals one of three outcomes when you're solving an equation with absolute value. If little d or big D are less than 0, there are no solutions. If little d or big D, of course those being distance, are equal to 0, there's exactly one solution. And if d is greater than 0, there are two solutions. So those are kind of your three options no matter what when you're solving. You know you have to get one of them. So let's use this to not even see what the solutions would be, but just to double check and give us a good hint or a good start of how many there would need to be. So we don't need to actually solve them. We just need to see the amount they would have. And it's all about what it's equal to. For example, the first absolute value equation by itself is equal to 3. 3 is D. So D is greater than 0, so because 3 is greater than 0, so this has two solutions. B, we're not in the format yet. We have to subtract 5. So then the absolute value of x plus 7 would be equal to 5 minus 5 is 0. And when it's equal to 0, there is one solution. C, we have to get the absolute value alone first by subtracting 1. So now that cancels out, and we have the absolute value of 3x minus 5 is equal to negative 5. That's a negative number, so this equation has no solutions. D, we have this absolute value is equal to 0.0001. Who cares that it's a decimal? It's a positive number. It's greater than 0, so there are two solutions. Then we have E. We don't have the absolute value by itself, so we have to subtract 2 first. So then negative 5 minus 3x absolute value equals negative 5. But we still have to divide by negative 1, which is really the trick there, because first it's equal to a negative, but as soon as I divide by negative 1, now the absolute value of 5 minus 3x is equal to positive 5. 5 is greater than 0, so that equation has two solutions. I don't know what those solutions are, but I can identify that there's two of them. It's a good trick to have to see if you're on the right track once you do get those solutions. Let's see a couple examples now where we actually go through with it and find the solutions, and we have our two different methods. So here, we want to get the absolute value by itself, so we're going to subtract 23. That gives us equal to 0. Then they'll divide by 2, 0, still equal to 0. So that means there's going to be one solution. So we can set 2x plus 7 equal to 0, solve for x, and get that x equals negative 7 over 2, or negative 3.5. Only one solution. And we knew that earlier because it was equal to 0, that absolute value. Here's another example. So first, we have the 2 times the absolute value of 5x plus 3 minus 15 equals 51. So we're isolating the absolute value first by adding 15 to both sides. So that gives us the 66. Then they divide by 2, which gives them 33. So this is going to have two solutions because it's equal to 33, which is a positive number. Now there's two strategies. The first, you are taking out the factor of 5, and then you are isolating the absolute value by dividing by 5. You have the absolute value of x plus 3 over 5 is equal to 33 over 5. So strategy number 1, you're definitely working with a lot of fractions. You're using the fact that negative 3/5 is your center, and you're moving 33 over 5 to the left, which gives you negative 7.2, and 33 over 5 to the right, which gives you 6. Again, strategy number 1, a lot of fractions. Strategy number 2, and I mean it's still right, but strategy number 2, if you're automatically setting each equal to negative 33 or positive 33, you're not working with fractions until the very, very end. Well, here, you're not working with fractions at all, and then you just have negative 36 over 5. So really, both will get you to your answers, but maybe strategy number 2 in this case will prevent you from making a mistake with the fractions. Here's another example. We have negative 7 times the absolute value of 6x minus 5 plus 11 equals 18. So again, we have to first isolate the absolute value, and then we have 2 strategies. So if we subtract 11 from both sides, we'll have negative 7, absolute value of 6x minus 5 equals 7. Divide by 7, and then negative, and we end up with the absolute value of 6x minus 5 is equal to negative 1. It's equal to a negative number, so automatically we know there are no solutions. D is less than 0. So you can't actually use either strategy. Before, it looked like you could automatically, but once you isolate the absolute value, you see that you can't. So you really just have to remember your equation rules, try to think of your strategies, and then try to use that approach of looking for the amount before even knowing what the solutions are.